evaluating expressions that have absolute value in them, and then solving absolute value equations. So just reviewing absolute value and the different things that come with it. So we're starting out with absolute value expressions. And just as a review, what is, or how would you define the absolute value of a number? What does absolute value mean? Carter? Yeah. So how far, or I'll say it's the distance. How far would be the distance a number is from 0. What are some things you know about absolute value? It's always positive, or it could also be 0 since 0 isn't positive or negative. So absolute value of a number is always positive or 0. And that's because it's a distance. So absolute value cannot be negative. What's the symbol for absolute value? Yep, 2 vertical lines. So like this would be the absolute value of x. Okay, so then just as a review, if I asked you what's the absolute value of 4, that would be 4. What's the absolute value of negative 4? Still positive 4. And then absolute value of 0 would be itself. So that's the only time absolute value will be 0 is if you're taking the absolute value of 0. Okay, so then I do want to say though, absolute value is always positive. However, when you're evaluating expressions that have absolute value, notice there aren't absolute value bars around the entire expression. So it is possible for problems like these that you will get a negative answer. It's just when you're working specifically with the absolute value part of it, that part then should be positive or 0. So if we look at example 1, oh, and it does say above, absolute value bars do act as a grouping symbol. So they act like parentheses. So when you have an expression that has absolute value bars in it, you do need to start inside of the absolute value bars, follow order of operations inside of the absolute value bars, get that down to one number, take the absolute value, and then evaluate the rest of the expression. So for 1, we have 8.4 minus the absolute value of 2n plus 5, evaluating that if n is negative 7.5. So we can substitute the value of n in. So 8.4 minus the absolute value of 2 times negative 7.5 plus 5. What I see happen with expressions like these is students then at some point end up just like dropping the absolute value bars and don't think of it as an operation itself. So don't ever get rid of those absolute value bars until you've actually taken the absolute value of what's inside. And I also see a common mistake is students might want to change this to positive 7.5 because it's inside absolute value bars. You need to evaluate all of this first, and then when it's one number, that's when you take the absolute value. So I'm going to keep the 8.4, keep the minus, have the absolute value of. Inside here, I need to multiply before I add. So 2 times negative 7.5 is negative 15. Still keep the 8.4 minus. Then I would add the negative 15 and the 5 to get negative 10. So now when I have one number in the absolute value bars, now is when I take the absolute value. So I have 8.4 minus the absolute value of negative 10 is positive 10. So I end up with 8.4 minus 10. And then 8.4 minus 10 is negative 1.6. That is the final value. So notice the final value is negative. That's okay. It's when I took the absolute value of negative 10, that's what had to be positive then. Okay, any questions on that example? Otherwise, I want you to evaluate example 2. Find the value of that expression if x is -2. Let's see if we get the same answer. I know you're not sitting in your groups, but you can kind of check with those sitting around you. Did you get the same answer? If not, what did you do differently? Stop me if you have a question or want me to check something. I just want to give you a chance to answer it.
Yeah.
Okay, it should be 1.5 or 1.5 or 3/2 if you had an improper fraction would be an acceptable way to write it. So notice you can change 3.5 to 3.5 if you'd rather have it written as a decimal. It is terminating. If you got -8.5, you did not take the absolute value. So you have to simplify in the absolute value bars all the way down to -5, then take the absolute value for it to be +5 minus the 3.5. Okay, any questions on those? Otherwise, we'll get into the equations. So just be careful, just in general, evaluating expressions with order of operations, easy to make mistakes. Just make sure you're paying attention to the steps that you're taking. So now absolute value equations, they don't always, but very often have 2 answers. So not always, but very often have 2 answers. And it is important that you check your answers, as we're going to see in some examples. So I have started with a very basic example. If we had the equation absolute value of x is equal to +8, what value or values could x be? 8, or it could be -8. Okay, +8 has an absolute value of 8. -8 also has an absolute value of 8. Okay, so there's 2 answers. So what I want you to notice here, the 2 cases that I'm going to refer to here are actually the 2 answers. But notice you take what's in the absolute value bars. In this problem, it was just x. And you have a positive case. I'm writing positive case, not positive answer. But you have a positive case and you have a negative case. Okay, so as we're going to see in the next example, you might then have further solving to do. But whenever you have an absolute value equation, you want to split it into its 2 equations, its positive case and its negative case, and then continue solving to get your answers. So if we look at number 4, because this one has more inside of the absolute value bars than just y, it has y plus 3 equals 8. So my positive case would be taking the y plus 3. So y plus 3 could equal +8, or y plus 3 will equal -8. So what's in the absolute value bars could equal the positive of the number that follows, or the opposite, the negative. But now for both of these equations, I have to now For both equations, to solve for y, I need to subtract 3. In the first equation, I'll get y is equal to 5. That's one solution. In the second equation, the equal sign here, negative 8 minus 3 is negative 11. So I have positive 5 or negative 11 are my two values for y. Directions again say to check. You should be substituting these back in just to make sure they do both work. So if I do substitute 5 in for y, I have 5 plus 3, that's 8. I know the absolute value is 8. If I substitute in negative 11 plus 3 is negative 8. Absolute value is positive 8. It is possible that one or both of your solutions, when you substitute them back in, might not work. So like I said, a lot of the time you get two answers, but not always. Okay, any questions on those two? Absolute value, set up your two cases. And I included some different types of examples. So now in example 5, the absolute value is not by itself. So when you have an equation where there is more than just the absolute value on one side of the equal sign, you want to get the absolute value by itself first. You want to make that note to yourself, get absolute value alone first. Before you set up your two cases, the absolute value bars, that expression has to be alone. So I need to get rid of that plus 8, meaning I would subtract 8 from both sides first. So I still have my absolute value bars. Absolute value of 3x minus 2 is equal to 1 minus 8, which is negative 7. Okay, now there's another thing about this particular problem that's a little bit different. Once I got my absolute value bars alone, I have a negative number on the other side of the equal sign. So we said absolute value has to be positive or 0. No matter what I put into this equation for x, when I take the absolute value, this side has to be a positive number or 0, meaning it will never equal negative 7. I can't get negative 7 on this side because I'm taking the absolute value. So now that I have this equation, I can just say there is no solution to that equation. And you can put that empty set symbol, or you could actually write out the words no solution. Okay, so I'm going to explain that again. The side with the absolute value bars, no matter what I put in for x, will have to be a positive number or 0, meaning it will never equal negative 7. Now, if you didn't recognize that, this is why it's important to check your solutions. If you didn't recognize that and you went through and set up your two cases and got two answers, always check. If you substitute them back in, you would figure out that neither of them would work. And that also tells you that it's no solution. So that's why it's important to check. In case you forget something like this, you can always check and still get that it's no solution. All right, so why don't you go ahead and solve equation number 6. Absolute value of a minus 5 plus 4 equals 9. So solve that equation. Get your answers, check them, or if it's no solution, make sure you have no solution. So now that you have a positive number still over here, now you can go to the next and now this is okay. One comment I have. So first of all, I have the work up here. I tried to catch it if you didn't have something right. So you would have to subtract 4 from both sides first. Then this equation is when the absolute value is by itself. That's when you split it into the two cases and solve them both. Now, just in walking around, I realized, second week of school, I realized this is review. I need a quiet, please. But it's already alarming when it's chapter 1 and I walk around and people are not taking notes and then get to an example and don't have a clue what's going on. Okay, it's chapter This will not be a good year for you. You need to pay attention to this, even though it's review. I wouldn't be reviewing it if I thought you all just knew it. And I'm walking around and there are plenty of questions. So you shouldn't have your computers out. You shouldn't have your phones out. Those are distractions for you. Okay? Calculators, you should have a calculator so that you don't have your phone out or your computer out. Okay, so example 7. This one's a little different. So we have absolute value of x plus 10 equals 4x minus 8. Absolute value bars are already by itself, so we don't have to move anything to the other side right away. We can just start out right away setting up our two cases. So this means our two cases is going to be this entire side. We want the positive of that side and then the opposite of that side. So one of my cases is going to be that x plus 10 will equal this side just the way that it is, 4x minus 8. Or my other equation will be x plus 10 equals the opposite of that side. So the opposite of the quantity 4x minus 8. So I will, when I solve this equation, I will have to distribute that negative through. I'm taking the opposite of all terms that are on that side. So I'm going to go ahead and solve this equation first. This is like 1x here. So to keep my x's positive, I'll subtract x from both sides. And then I still have 10 equals 4x minus x is 3x minus 8. I would then need to add 8 to both sides. 10 plus 8 is 18 equals 3x. Divide by 3. 18 divided by 3 is 6. So one solution I'm getting is that x is 6. Or, now if I solve my other equation, so here this is like a negative 1 that is in front of that parentheses. So I need to distribute the negative 1. So I have x plus 10 equals negative 4x plus 8. So when I solve this one, I'll add 4x to both sides. So x plus 4x, I would have 5x plus 10 equals, still have 8 on the other side. Subtract 10. 5x will equal 8 minus 10 is negative 2. And then divide by 5. I could leave this, I'm just going to write it next to here. I could leave it as negative 2/5. That is a terminating decimal. And because it's important that you check your answers, a decimal might be easier to plug in if you can change it to a decimal if it's not repeating. So negative 2/5 is negative 0.4. So those are the two answers that I got. So as I said, it's important that you check both of these. So I am going to show the check for this one. So hint, hint, one of these isn't going to work. That's why I'm showing this. It's important to check all of them, and I've talked about that, but for one of these, because of x being on both sides, I'm going to write it out. So if I check, first of all, x equals 6, I'm going to check that one first, plug 6 in for all of the x's, and see if the two sides are equal to one another. So I have the absolute value of 6 plus 10. I want to know, does that equal 4 times 6 minus 8? Are those two sides equal? So on the left side, I know 6 plus 10 is 16, and the absolute value is still 16. So I get 16 over here. And on the right side, I have 4 times 6, that's 24. 24 minus 8 is also 16. So those sides do equal each other. That means x equals 6 is a solution. It works. If I check x equals negative 0.4, so I have negative 0.4 plus 10 in absolute value bars. Does that equal 4 times negative 0.4 minus 8. Negative 0.4 plus 10, that would be positive 9.6, and the absolute value is still positive, so this side is 9.6. And then on my calculator here, 4 times negative 0.4 minus 8 is negative 9.6. Okay, 9.6 and negative 9.6 are not the same number. So that means this is not a solution. X equals negative 0.4. It is a solution to this equation that I wrote, but not to the original one I started with. We call this an extraneous solution. Now, you don't have to write, say this was on a test, you don't have to write by it that that's an extraneous solution. I'm just writing that in for your notes for those purposes. But extraneous solution basically means it's a false solution. It's a solution to the equation we wrote to help us get the solutions to the original. But when I plug it back into the original, it doesn't work. So my only solution is x equals 6. Okay, so it's possible when you solve an absolute value equation that you'll get 2 answers. Most of the time you will. It's possible that you get no answers, like in example 5, or you might only get 1. So 2, 1, or 0 are your options for the number of solutions you might have. Any questions on 7? Okay, 8, really quickly, I just want to make sure you would know how to start 8, and then I want to leave time for you to work on the assignment and make sure you can get onto the textbook. Absolute value bars for 8 are not alone. What would we have to do to both sides to get rid of the negative 3 that's here? Divide. One important thing for you to know, you cannot distribute. So if you have absolute value bars, you cannot distribute the negative 3. You can only distribute if you have parentheses. You cannot distribute for absolute value bars. So you would have to divide by negative 3 first. And then you have the absolute value of r plus 4 equals, this is now positive 7. And then you would continue. Okay, so don't look at that and say, oh, there's negative 21, there's no solution. You have to get rid of the negative 3 before you can determine if there is a solution. And to get rid of the negative 3, you divide, and then you continue. Okay, so if you work through that one, I will check for you if you have it right. But your assignment is out of the book.